I'm Rajan, and I'll be talking about a project which I've been working for more than 2 years, crowd research. So if you were at UIST last year, you may have seen a paper called Boomerang with a lot of authors. Or if you were at CSCW earlier this year, you may have seen another paper called Crowd Guilds with a lot of authors. And I've received a lot of questions, and people were always curious, like, how did you do that? And what were these papers about, and how did that research occur? So today, I'll be talking about the meta process and how did we actually got all of these people to work on massive research projects. So today, this talk is on crowd research, open and scalable university laboratory. So research is sort of the domain of privileged few. Those who are able to attend prestigious universities can have access to experiences that support open-ended inquiry and launch careers. This map, for example, shows the concentration of top 50 universities worldwide, mostly concentrated in North America, Europe, Australia. And we know that research experiences are important because it increases not just the possibility of getting into STEM careers or likelihood of using faculty recommendation for jobs, they impact essentially the upward mobility of people's lives. But the vast majority of the people cannot access these kind of experiences. So this map, for example, shows where the population density of the world lies, mostly, for example, in India, China, Africa, Eastern Europe, and other places. And the effect of this is that it creates a research ecosystem that undermines or underrepresents minorities and developing regions, and a literature that overlooks their perspectives. And I think it's a huge problem. So 2 years ago, we thought about this problem, and we created crowd research, a technique that enables anyone from anywhere to collaborate on open-ended research projects, where participants could collaborate to brainstorm, execute, and publish the project under the leadership of a specific PI. And the goals were twofold. Number one was to give access to training and research experiences that can enable upward and educational mobility. And the second was to convene the crowd of hundreds or thousands of people on a single ambitious project. To date, crowd research has enabled access to hundreds of people from 6 continents, produced multiple crowd-authored papers, and provided upward mobility as people have gone on to places like CMU and Stanford. And while I'm talking about these research experiences, it may remind you of projects like the Polymath project or Folded. But the way we are trying to address this is that research is not a linear path from idea to a result. It's very open-ended. We don't know what we're aiming for because it's all exploratory. And so what if we don't, or if we're not working for predefined goals, but something so open-ended that we don't even know where to start from? So as part of open-ended research, that's what the crowd was working on, and that's what we were focused on. But then this also comes with like major challenges. Number one was about coordination. How can we prevent the project from moving in different directions? Or when people are posting like hundreds of thousands of messages per week? How do we provide proof that the participants made substantial contributions to the project when no central authority can actually assert this? To address these challenges, we created iterative crowdsourcing technique, which consisted of weekly cycle of open contribution, synchronous collaboration, and peer assessment. And for the credit, we created a decentralized mechanism where people could give finite credits to each other, enabling a graph centrality algorithm and to determine credit and author order. So far, as part of the crowd research initiative, there were 3 projects. Number one was HCI, led by Michael Bernstein at Stanford, and the project was to create a new crowdsourcing marketplace. It was very meta. We basically got crowd to create a crowdsourcing marketplace. The second project was in computer vision, led by James Davis at UCSC and Serge Belongie at Cornell Tech. And the goal was to create hybrid crowd computer vision algorithms. The third project was in data science, led by Sharad Goel at Stanford, and the goal was to create the world's largest wisdom of crowd experiment. So how did we coordinate this whole process? Our process was basically made up of 4 stages that followed a weekly iterative cycle. It started with open call, where we basically set up a web page and shared it across different universities, social networks, mailing lists, and made an open call to people from around the world, whether they were undergraduate students or whether they were professionals. So people formed a lab of hundreds. More than 1,500 people participated from 6 continents, roughly 65 countries. 91% of the people had no prior research experience. 74% of the participants came from universities that ranked below 500. Most of them were undergraduates, and there were also high school students who were participating in these research experiences. In terms of staff, there were 4 professors, 10 research assistants, and 3 projects in HCI, computer vision, and data science. Once the group was onboarded, we started with Hangouts for weekly group meetings. And we invited people who were performing well or who were very curious on the video side of the Hangouts, while others coordinated and learned about these kind of meetings through the Slack channel. It was very similar to just like a professor talks to their students once a week. So some projects lasted for 12 weeks, while some are still continuing after even like 100+ weeks. We generated more than 500,000 Slack messages and about 1 million views on Wiki, which was presented for informational purposes of the projects. Just like a university lab, we also had guest lectures. So Andrew from Coursera, Peter Norvig from Google, Anant Agrawal from edX, they were very excited about this initiative, and so they came and gave talks to the students about their research experiences and how it can impact others. Once group meetings happened, like they were also given, the crowd was given milestones. Milestones were basically actionable items for every week where the crowd could work on specific things towards the progress of the project. During the initial phases, there were common milestones, so everybody was working on same things and generating a lot of ideas and a lot of questions. But as and when these research questions were getting more and more confined, they were broken down into different areas such as engineering, design, and writing, led by ad hoc leaders, whom we call DRIs, or directly responsible individuals. Our milestone looked something like this. For example, in this milestone, they were asked to create a low-fidelity prototype for each item, and so crowd did that. So they created prototypes and storyboards. They also did engineering, data analysis, writing and brainstorming, task planning, and many other ways of contributions, just like a PhD student, for example, does. Once these contributions were made, the next phase was about peer assessment. And we really wanted to scale this because a professor's or the PI's time was limited. Our time was limited. So how do we understand which were the top ideas for a given specific week? So we created a Reddit-like tool where people could upvote and post their submissions, and we could get the top ideas every week as a way to assess in which direction to move further. And so this formed like the high-level overview of how we coordinated as a 4-phased process. Credit. So to create upward mobility, crowd research really must signal participants so that they can leverage it for school and job applicants. Because if there are so many participants who are working on something large, how do we know like which participant has contributed and to what extent? How do we quantify that? Which would help in their author order if they're publishing or recommendation letters. Because it's really hard. Integrated collaborative efforts can easily get obscured, and PIs don't necessarily had an overview of what everybody was doing. For example, the paper which was presented last year, how did this author order how did we even figure out this author order? So we took this whole credit argument to like graph problem, where each participant allocates 100 credit points to other participants based on their assessment of who impacted the project. So nodes here are like people who were participating, and the 15 is the score which was being sent. And this resulted in a weighted directed graph. We further applied graph centrality algorithms such as PageRank, and the intuition behind that was to identify nodes that are receiving large amounts of credit, weigh those nodes' allocations heavily, and iterate until convergence. And one of the reasons for that was to also propagate each node's score in proportion to its outgoing wedge weights. There could be strategic behaviors. For example, there was a situation where a small group of people were interfacing with just one person, and that person was interfacing with the rest of the group. And so when the time came of like credit distribution, they were basically giving all of their scores to each other, forming a link ring. There could be 360-degree reviews occurring. But formulations of centrality algorithms such as PageRank can correct most of these attacks. By the way, we have created a tool called credit.stanford.edu where you can go and like try it on your own if you want to determine author order for your own projects or any other situation which demands more democratic way of like choosing ranking. Next, we deployed crowd research. And I talked about the technique, but does that technique really provide upward mobility and impact? I talked about the credit, but what effect does this decentralized approach have on peer-authored rankings? I mentioned that this work really got people from all over the world to come and participate. And it produced real-world systems and experiments. So the HCI project has produced demo crowdsourcing platform, which is live and has successfully used to create a data set of 100,000 question-answer pairs on 500+ Wikipedia articles. The Wisdom of Crowd experiment has become the largest of its kind with 1,000 questions across 50 domains and has attracted more than 500,000 responses. It has produced top-tier papers. So Boomerang was presented last year at UIST. Crowd Guilds was presented at CSCW earlier this year. And every project at least produced one work in progress in HCI, computer vision, and data science. We also provided upward mobility. So we surveyed the participants whom we had written recommendation letter, and 21 of 33 surveyed people were admitted to a place of their choice. They have gone on to places like Stanford, Berkeley, MIT, CMU, and as part of that application process, they were also asking for recommendation from their home university professors or people whom they had worked with. However, a median of 0 other letter writers from institutions ranked better than 500 worldwide. Thus, the crowd research PIs were the only recommenders from top-tier universities for many participants. And this was reflected in people's feedbacks. For example, there was one student from India who is now at Stanford, and he mentioned that these opportunities weren't available to us back home, and that he learned about the research methods as practiced in universities such as Stanford, and definitely went a long way in helping me secure admission. Next, we wanted to understand how diverse were these authors. And they were, crowd research paper authors were diverse than others at the conferences they published. So for example, at WIST 2016, Boomerang paper was published. And we wanted to compare what was the diversity for crowd research paper versus all the other papers. And we found that crowd research authors, 57% of them were from universities that ranked below 500 worldwide versus 12% for all the other papers. So we basically analyzed every paper that was published last year at WIST. The Crowd Guilds paper was submitted at CSCW, so we also wanted to understand for CSCW. And it was 58% of crowd research authors were from universities that ranked below 500, while 11% for all the other papers. For WIST 2016, we also wanted to understand where they were coming from. And so 42% of the crowd research authors were from the countries that ranked below 50 worldwide in GDP per capita, and only 2% for all the other papers. For CSCW, it was 35% and 6% for all the other papers. The crowd led the ideation. This thematic coding of Sankey diagram shows how different ideas were evolved over the period of like several weeks. So for example, in the HCI project, on the left, like these are the ideas which were being proposed. And in the end, like by the end of 5 weeks, there were certain research themes which were starting to emerge. And so open governance on the top became the Crowd Guilds paper, reputation and ratings theme became the boomerang paper, and input and output translators is still a work in progress. The crowd also led the writing of these papers. So based on the number of edits, we found that crowd did 84% of the edits while PI did 16%. We see that PI did most of the edits in the introduction section, which kind of makes sense because introduction is really hard section and needs more polishing. But what I'm trying to convey here is that it wasn't that, that the crowd did work and then PI redid everything. It was crowd who basically led the paper writing efforts. I also talked about PageRank. But what impact did PageRank have on credit distribution? To understand that, we basically normalized raw summed credit scores and PageRank adjusted scores to a sum of 1, and regressed both of them on observable collaboration behavior metrics, such as GitHub commits, number of Slack messages being sent, or leadership positions being held, and compared beta estimates across the regressions. The column here demonstrates which behaviors were positively or negatively correlated with someone's final PageRank score, ranging between 0 and 1. So for example, it could happen that making more GitHub commits has significant positive correlation with higher author order. These next columns show us what happens with and without PageRank. But what's really interesting is looking at the last column, which is the difference between these two columns, which activities were more emphasized with PageRanks, which weren't with raw votes. And what's really interesting about this is that when we compare these beta coefficients, things like committing code or taking a leadership positions were more emphasized with PageRank, and things like posting on Slack messages was less emphasized. So what I'm trying to convey here is that more actionable things like making code commits or leading certain efforts is valued way more than just being on Slack. And in practice, we saw this effect. So this is a raw vote network where, if you notice on the left corner, there was sort of a link ring forming, and a person with the ranking 2 is getting major votes. What we realized was that this person, even though is getting second authorship, it wasn't fair depending on the contributions they made. So when we applied PageRank, the ranking fell from 2nd to 5th, which was a very fair way of assessing this person's contribution, and this really was appreciated in the community because they felt like it's a very fair way of it's a very fair author order. In general, the reflection for this project is that computation and crowdsourcing can scale not just the teaching of new skills and the execution of open-ended research, but the experience of research and upward career mobility as well. And as we are going forward with this, we imagine that decentralized evaluation could help even traditional groups like industry or like various groups within universities and escape the tyranny of just top-down review. Or projects that reach more people can operate at a larger technical scale than current traditional CS research, therefore enabling and opening routes to new and larger scale remote collaboration efforts. With that, I would like to thank you and also invite researchers or faculty to reach out to us if you want to run a crowd research style project of your own. Thanks.
Hi, Juho Kim from KAIST. Rajan, this is really exciting. Great to be seeing this presented at UIST. So I have two quick questions. One is, what kind of resistance did you have to fight against from those sort of traditional sectors? For example, when we were dealing with you guys' first work in progress for UIST 2015, we had to fight with the publisher because they were basically saying there's no way to have 50 authors in the system. So we had to sort of convince them it is actually possible for all these people to have made research contributions.
Yeah.
So I'm curious as to sort of hear what other instances of things like that you had to sort of deal with this kind of new model. And the second question is, so I think a lot of the arguments you're making are kind of similar to what we saw with MOOCs when they first came about a few years ago. Right, so a lot of people were really excited about providing access to high-quality education, but there was the morning after when everyone felt a little bit bitter about seeing a lot of high drop-offs, and also are people actually learning So my question is about, are people actually learning to do research better? In that the apprenticeship model that we have in a lot of the academic institutions is basically encouraging people to go through the entire cycle of research by themselves. And with the crowd collective method, did you see that each person in that pipeline sort of masters that whole process?
Right. Great questions. So for number one, we did, so there were like different kind of resistances. So number one was like where you helped with, like figuring things out with the ACM. But when we were like starting this project in the first place, there was sort of like this factor of convincing people or like faculty to even show that this kind of thing can work. And so getting more people involved, like from faculty side, that let's work on more interesting and like large scale projects was very hard. And I think that now that we have a demonstration of like how we can do something like this, that may, that resistance may be lowered. With respect to your second question, I totally agree, like, that there has been certain like problems with MOOCs, but I'm also seeing like MOOCs have also impacted many people's lives. When I see, whenever Andrew Ng, for example, posts on Facebook, a lot of top comments are about like, thank you for like, I'm here and I'm at this place and it was all because of Coursera and those kind of things. So it has like some limitations, but it also has a lot of like positive impact. And with this one in particular, when we are talking about like drop-off rates, it wasn't as much with respect to moves. So like, even though there are like some projects we have extended toward like 100+ weeks, there's still like significant number of people like contributing. People have learned these skills. They have gone on to like industry and like different universities and continuing to make research contributions, which they weren't planning to do otherwise. So, yeah.
And we only have time for one more question, and I'll have the next speaker set up while you take his question.
Stephen Dow, UC San Diego. Very cool work. I was wondering if you had any qualitative stories you could share that maybe, like there's always a tendency to sort of share the rosiest picture about an approach that you're demonstrating about, and you kind of got at it with your response, but like where someone felt disappointed or they didn't get enough credit or it was just messiness in terms of how it moved forward. So can you share a story about how it didn't work?
Definitely. So of course, like the high-level photo, the high-level thing was shared in the start, but there are like a lot of details into that, and there were like a lot of positive movements, a lot of some negative movements as well. One of the stories which I can think of is that, and which really inspired us to evolve our credit mechanism. So one of these stories which I remember instantly is the story of credit, and that's what helped us like evolve our process. So originally we were using the credit mechanism around like just the raw votes, and we thought that it would work until we found out that there was like some strategic behavior like linkering happening, and that really upset a lot of people, which forced us to rethink our approach and how do we like handle these kind of situations, and then like we evolved our algorithms. We made some restrictions that like when you're sharing your 100 credits, you cannot give more than 15 credits to other people, which we had not originally considered. So there were like a lot of like learning while we were experiencing people's instant reaction. This is just one of that, but like yes, I can share like more stories.